Okay, so we've got question 2 of the Pythagoras 3D. It says a pyramid and a net. Calculate the lengths and give your answers correct to one decimal place. The height of this square-based pyramid is 7 centimeters, so h is 7 there. Find the slant height s. So we need to look at this right-angled triangle there. We know that the height is 7. We need to know the slant height s, so we need to find out this length at the bottom. So if you think about the bottom of that pyramid, it's a square, and it's got sides of 5.4 all the way round, and then you've got diagonals in that, and then half of one of those diagonals is the thing we're looking for. It's the base of the upright right-angled triangle that we need in the other calculation. So if I call this, let's call it x. So both of these are x, and you've got a right-angled triangle in there where the two diagonals of a square cut each other. So basically you've got x squared plus x squared equals 5.4 squared. That's Pythagoras. X squared plus another x squared equals 5.4 squared. So in other words, 2x squared equals 5.4 squared. So x squared itself will be 5.4 squared divided by 2. And x will be the square root of 5.4 squared divided by 2. So I'll get that in decimals. The square root of fraction 5.4 squared divided by 2 comes to 3.818, let's call that. 3.818. So now we've got enough information in the upright triangle that had the height, which we were told was 7, the 3.818 that we just worked out, and then we've got to work out that slant height s. So again, that's Pythagoras, that's a right-angled triangle in there, and 7 squared plus the 3.818 squared is going to be equal to s squared. So s is just going to be the square root of the 7 squared plus the 3.818 squared. So let's do that on decimals. Clear all that. Square root of 7 squared plus 3.818 squared, 3.818 squared. Obviously I've rounded that off a bit, but because I've gone to 3 decimals there, I should be okay to 1 decimal. And that comes to 7.97. So in fact, to 1 decimal place, that will be approximately equal to 8. So I've got the slant height as 8 to 8.0, which is as good as 8 to 1 decimal place. Okay, on to the next question. It says, here's the net for an open box. Find the maximum length of pencil that can be placed entirely within this box. Okay, so if we imagine that actually constructed, so 7 one way, let's make that the 7, that the 4, and that the 8. Not really to scale, but it doesn't matter. And we want the corner to corner length. So thinking about the bottom of that box with 7 and 4, the diagonal of that is going to be the square root of 7 squared plus 4 squared. So the square root of 49 plus 16 will be the square root of 65. And then thinking, so let's just sort of pencil that in. So we've got a diagonal there, that's the square root of 65. And then we've got the height of the box, which we know to be 8. And then for the corner to corner diagonal of the box, makes a right angled triangle with the two that I just mentioned. So 8 and the square root of 65 form a right angled triangle across the diagonal of where the hypotenuse is across the diagonal of the box. So let's call that P for pencil. P squared equals 8 squared plus the square root of 65 squared, that's Pythagoras. P squared equals 64 plus 65. P squared equals 129, so P is going to be the square root of 129. So let's do that on Desmos. Square root of, let's clear everything, square root of 129. 11.35 and a bit, so that's going to round to 11.4. So let's just mark that. And there we are.